Good morning, good afternoon, good evening, and welcome everybody to this presentation today organized by Klein. I have a great pleasure to walk you through some of the key insights that we gained during the last coverage of our report that basically analyzed the various market opportunities that are emerging in the ongoing electrification of passenger vehicles. And I am really happy to say to highlight and navigate you through some of the interesting insights that we gained during this research. Before that, I just would like to, in this slide is illustrating a client focus on sustainability titles. The ongoing or the present report is basically connected to a broader emphasis on client covering a number of sustainability-driven disrupting forces that are having a direct implication in our market, in the finished lubricant market. So as you can see, we have covering extensively a number of titles where the efforts toward cleaner, carbon neutral solutions is one of the main targets. Also, I would like to say that in connection to today's presentation, the electric vehicle fluids market consumer volume, we are also very soon we're going to start a new research effort covering the electric vehicle fluids market opportunities, but in this time in the commercial vehicle segment. With that few words, I would like just to describe briefly what is the scope in the methodology that we have applied during this specific research. As you may know from Klein previous webinars, our emphasis is on primary research, getting direct hard-to-obtain information from the stakeholders. In terms of the geography, we have covered the 4 major countries or regions that are basically the epicenters of this transformation in electrification of passenger or personal mobility. In that case, we have included United States, China, Japan, and also Europe. We provided a consolidated view of 3 major country markets like Germany, France, and the UK. The base here is 2020. We are providing a long-term outlook for up to 2040. That is coming from our demand model that we have applied for different products that are mentioned here. Engine oils, which are still used in hybrid vehicles, transmission fluids, coolants, and greases. The data inputs has been based on the recent events covered or that had happened in the marketplace over the last months. However, in Klein, we recognize the high dynamic of this environment, the electric vehicles industry. And for that reason, I just would like to reiterate that the Klein's commitment to continuously monitor, review, and update our projections based on those the most recent industry events. In terms of the coverage for the electric vehicles, so we have covered all types of electric vehicle powertrain technologies. So from fully electric vehicles, including battery electric vehicles, fuel cell electric vehicles. We have also included hybrid vehicles, the whole range of hybrids, plug-in hybrids, mild hybrids, and fully hybrid vehicles. And the most likely scenario, the long-term projections are based on the most likely scenario according to the client's view. So with these few words about the scope and the methodology, I would like just to go to the next slide. But before that, I would like just to add a polling question here with Vera. Thank you, Vera. So the question is, what do you think are the 2 major barriers preventing a faster deployment of electric vehicles? And we have a number of options here. And you're already voting.
Yeah, when I get to about 70%, I'm gonna stop. It takes usually a few seconds. You're getting there. You're really fast, everybody. Sorry. I'll be quiet.
Excellent. very reactive and very, engaged audience today. Very glad.
Yes, and you can comment on that. Actually, we are ready.
We're ready.
2, 3, stopping the poll now. Thank you, everybody. You can comment on that. It's interesting.
Excellent. Yeah, indeed. So we see here that the 75% is saying that the major barriers is lack of infrastructure, charging infrastructure, followed by shorter drive range density, vehicle cost third with 29%, and growing electricity demand 19%. So let's take a look on those in the next slide. So certainly, those are the major barriers that are preventing for a faster deployment of electric vehicles and passenger vehicles, and all of them, regardless of the level of or the lever of impact that they are exerting on the electric vehicle industry. One commonality is that all is related to battery technology. So when it comes to cost, to driving range, infrastructure, once the battery technology, is supposed to undergo a major transformation, we can expect that all those barriers could be, overcome. But certainly, on the other side, we see that the major driving forces that are promoting the penetration of electric vehicles include mainly sustainability. As I mentioned at the beginning, this is the main trigger that has started the entire transformation to electric vehicles. And those efforts in terms of carbon neutrality wouldn't be possible without the synergetic effect of, supportive governmental policies in the way of, internal combustion engine sales or bans at the city, local, or state level, but also without direct incentives in the form of fiscal stimulus or purchase subsidies, for example, but also indirect incentives, which are also very effective in promoting the penetration of electric vehicles. So that in terms of, what are the different major forces that are promoting and also the major barriers in the area of electric vehicles penetration. As we can see, the major or leading OEMs, not only the so-called legacy OEMs, as mentioned here, a few of them, Volkswagen, GM, Nissan, they are all reacting to these fast changes, and also the novel all-electric, electric vehicles manufacturers like Tesla, Rivian, Lucid. All of them are announcing huge investments of financial resources to the expansion of the electric vehicle manufacturing capabilities. So in order to attain a certain level of sales percentages that will be exclusively electric vehicles within the next decade or two. So this is some of the timelines and some of the pledges for, announced by these industry leaders. Now, in terms of the projected electric vehicle population for the select countries here, the 4 regions or countries. So according to the most likely scenario in Klein's view, electric vehicle population is going to see a major exponential growth with accounting for 3% in 2020, clients expecting that all of those technologies, battery, hybrid, plug-in hybrid electric vehicle, will account for about 40% in 2040. It's also worth mentioning that the change or the transformation will be also at geographical scale. As you can see in 2020, in the upper side of the chart, the US and Japan are the largest, or they accumulate the largest EV population, mainly because of the high number of hybrid vehicles in those 2 countries. While in 2040, we can see that China and the US will be the largest markets in terms of EV population. mainly because of the presence of the battery electric vehicles in China. In the case of the US, it would be a more, I would say, diversified population with different type of EVs participating in that market. What that means for the electric vehicle fluids market. So you can see here clearly the difference in clients' projections. In 2020, the EV fluids market means the fluids are used in electric vehicles, including engine oils, greases, transmission fluids, and coolants. They all account for about 250 kilotons in 2020 in those 4 select countries. By 2040, the volume will be about 1,500 kilotons in client's view. The major markets will be China, US, and Europe, all of them accounted for almost the same type of share of participation. Now we take a look on what is the expected demand forecast for electric vehicles fluids in terms of the electric vehicle powertrain technology. As you can see on the bottom of the slide, the fastest growing segment is the plug-in electric vehicles, followed by battery electric vehicles, and then hybrid electric vehicles are posted to undergo the most modest growth compared to the other technologies. This could be attributed also to the hybrid electric vehicles gaining some signs or maturity, especially in key countries like Japan or in the US. In terms of and before that as well, we have some polling questions as well. Vera, if I can ask you for showing the questions.
Let me try to pull this up. Where's it go?
Right. So in your opinion, what will be the fastest growing type of EV fluids? Engine oils, coolants, greases, transmission fluids. We have 4 different products categories here, and we are receiving a lot of answers already. Interesting. So we can end the poll, Vera?
Yes.
Yeah.
Got you.
Excellent. So, well, 66% of the audience believes it's coolants, followed by 25% transmission fluids, 8% greases, and basically engine oils are not supposed to expect any growth in the forecast. Let's take a look on our view. And is in the next slide. Absolutely, we expect that the coolants are the ones that will be, the product category that will be undergoing the major side of fast growing market, around 12%, followed by transmission, greases, engine oil. This will be really sort of an inertial kind of growth based on, growing, aging hybrid vehicles. So, but in general, coolants and transmission fluids are the 2 product categories that will be, undergoing a major growth in the EV fluids market. In terms of the market opportunities by the market segments, we can see that obviously without any surprise, the electric vehicle fluid market will be mainly a factory fill market. That is particularly true for the battery electric vehicles, as you can see in this slide. However, with growing and aging EV population, especially for hybrids or plug-in hybrids, it can be expected that there will be also some market field or service field aftermarket opportunities in the regions that we cover. So, but essentially, the major market, the most important route to market in early stages of the EV fluids development will be concentrated in the factory field segment. This slide is just to illustrate, because so far we have been covering or talking about the opportunities of the electric vehicles fluids in terms of volumetric. In terms of value, I think that is also very important to highlight that not all the electric vehicles that will be served by the the same type of mainstream lubricants that are being used so far. As the electric vehicles technology will advance, it will be an increasing necessity for the formulations of dedicated and specialized fluids that could be performed in an adequate way according to the new novel operation conditions. So just to illustrate the different type of architectures here, we have a nomenclature that is not standard, but is used by major, the major players in this industry, and those are architectures or let's say alignments are designated by P, from P0 to P5, and those are basically indicating what is the location of the key components, mainly the electric motor, and what is their location in the context of the transmission fluids, the transmission box, sorry, or the internal combustion engine. So we have the P0, P1, that in the case of the hybrid configuration, the electric motor is located before the internal combustion engine connected to a belt, or in the P1 is after the internal combustion engine and is connected to the crankshaft. In the case of P2, we have the electric motors that is located between the clutches. In one case, the electric motor is, for example, before the transmission box. In the gear box input, P3 is after the transmission box in the gearbox output, and then the architecture P4, which is in this arrow, is located in the electric motor in the axle, and P5 is basically in the wheels. But I will explain a little bit more about the implications for the electric vehicle fluids formulations or performance requirement, I would say. So in the case of the architecture P4 and 1, I would like just to say there is no one single technology that is prevailing across regions, and not even one OEM has one preferred type of architecture. Most of the time is a mix of the architectures, but in some regions it can be seen that a number of players tend to be or lean to be using a certain type of architecture for certain or various cost reduction considerations, or for technical commercial reasons. So for example, in the case of P0 and P1, we see that this is the low cost of integration is involved and is the simplest form of powertrain electrification. That's mainly used in mild hybrid type of electric vehicles. It is used mainly in China, but also in US, in Europe, and to a certain extent. And what is more important for us is to see what is the need or the pressure exerting for a dedicated electric vehicle fluid. So we can see here that the need for dedicated EV fluids is low. Then we have P2 configuration. This is considered promising technology because it have improved cost, operational flexibility balance. Here we have, for example, dedicated hybrid technologies, power split type of architectures, the planetary gear set. And in this case, there is a higher level of integration of the components, as I mentioned before. So the electric motor is located within the transmission house, within the transmission box, in that interface of mechanical, electrical, environmental conditions exert pressure for a more dedicated type of EV fluids. So far, in the case of single speed gearboxes, ATFs are being used. However, in the future, it's believed that approach will be not enough to ensure the proper, operations of those systems. Then we have P3 architecture is basically used mainly in China in plug hybrid electric vehicles. Again, is low cost or level of integrations. Therefore, the need for dedicated EV fluids is 4. P4 is the most important type of architecture that is present in battery electric vehicles. And here we have basically observed the ongoing integration trend where the electric motor, the power electronics, and the transmission systems are all housed in one single system, and therefore there will be a very high, I would say, need for dedicated electric vehicles that will be, necessary not only for lubricating or tribological requirements, but also for cooling, for heat absorption properties. The last one, P5, is actually not commercially available. This is the electric motor that is located in the wheels. Having said that, we can see that there are 4 emerging or most important stressors that are leading to specialized EV fluids. And those are basically compiled in this slide. Those are heat transfer. It has to be a fluid that will be efficient at transporting or transferring the heat that will have created at different stages. And also it will be important to differentiate the type of the heat that is produced, if it's mechanical induced heat in bearings or electrically induced heat on electric motors and power electronics. Material compatibility is also very important because of the different novel materials that are used in electric vehicle powertrains. Electric conductivity is also important. Dielectric fluids pose as a very important, adequate base oil fluid alternative for immersive cooling. And then at the end, durability, which is actually one of the most important, a very important aspect that is related to thermo-oxidative resistance of electric vehicles. So this will need a whole rearrangement of the way on how electric vehicles fluids will be formulated, take into account a different tool of alternatives, mainly in the use of synthetic base stocks or alternative fluids, but also additives and perhaps, non-oil related fluids in the case of fluor-based fluids or refrigerants. This is continuing the area of coolants, because as you recognize, this is one of the most important areas in the development of electric vehicles. Just here is to illustrate what are the different type of thermal management methods that are used currently, and what are the key components that requires a special effort in terms of cooling thermal management. So we have different parts that need to be cooled, let's say, or to where thermal management is necessary or indispensable, I would say. Those are battery cooling, power electronics, cooling of the e-motor, and cooling of the fast charge of the charging stations in general. The most important area where huge research and development efforts are being devoted is certainly in battery cooling. Power electronic and cooling of e-motors, as mentioned, in the case when they are integrated in one single module, there are alternatives where the transmission fluid use is also performing the cooling performance. In the case of battery cooling, there are alternatives that are used, like the air cooling that are used especially in a smaller city urban type of cars that has small batteries. Indirect liquid cooling is used by some of the leading players here, like Tesla or Audi. Is based on water glycol technologies. And then also indirect liquid cooling based on the expansion of a refrigerant in the heat exchanger system that is basically using fluorocarbon hydrofluorocarbon compounds. And the next stage is basically direct liquid cooling, where there is a lot of market expectations because it seems as the next generation of the thermal management. However, it still is on R&D and research and development stage, not yet commercially available. Is offered or is present in certain very niche markets like ultra premium luxury cars or racing cars, for example. Is also used in data service in data centers. Finally, as we see the transformation of the electric of mobility becoming electric, is also a transformation where we see that mobility is getting connected, is getting smart, where the OEMs or vehicle manufacturers will gain a certain level of prominence. It will be more a B2B market, where OEMs franchise workshop will be the primary points of service, and certainly we will see a higher presence of genuine oils, at least in the early stages of this transformation. Factory field will be certainly the market showing the highest opportunities. We see also that in line of this transforming or evolving ecosystem for electric vehicles, we see that number of players will be offering mobility as a service based on subscription agreements. Something that is being proposed in the US by Tesla. It might be also high synergy with the car sharing, ride hailing industry, and certainly also to the autonomous vehicles industry. Overall, the electric vehicles manufacturers will, are increasingly using services based on artificial intelligence, on the Internet of Things, offering remote diagnostic services, and using also user-friendly, offering user-friendly applications as well. And also an increasing use of mobile services and greater use of online sales and service booking tools. This is something that it has gained a lot of, it was boosted by the COVID pandemic, actually, and we believe there will be certain inertia in that market in the coming years. And with that said, I believe that I am at the end of my presentation today. If there is some interest for these titles or the incoming titles dealing with the commercial segment, those are the contacts here. Thank you very much for your attention, and we can open the floor for questions.
Yes, we have thank you, Charbel, it's wonderful. We have a few questions that we can still answer. Unfortunately, we have to drop and run to another event today, but at this moment, we still have a few minutes, and I'd like to, Charbel, if you could answer this an interesting question, that you actually did show significant service fill volume, but I don't think you revealed if you have any drain interval forecast for the EV fluids. So what is our drain interval forecast for the EV fluids? Is this something you can reveal?
Drain intervals, we have analyzed that. We have drain intervals for, we're looking at the maintenance papers from the different OEMs. We put some type of, ranges for that, but I don't know exactly top of my mind. So perhaps I can get you to that answer offline. We can discuss about that.
Yeah, I'll take a note, and actually you'll get all the answers by email after this presentation. And another question is also about timing and forecasting, which is kind of quite tough. But the question is about the penetration and timing of directly cooled fast chargers. Is it something you can say from the top of your head?
Yeah, that's certainly a good question, and I was wondering about also, and that's something that I have been, it was a topic of discussion during the coverage of this report, but it was more centered into the direct liquid for batteries. And in that, what I was basically collecting was a common view that, at this certain stage of technological development, which is really taking place very fast, cannot be discarded or eliminated, that within 5 years we can see some penetration of direct liquid cooling at the for batteries. And I would say that that could happen, that could be applicable as well for fast charging, in the case of fast charging cooling. 5 years is giving now as the sort of period of time where there is the next jump into commercialization is happening. Technologies are available, is ample number of players that are already operating in that area, that are testing and doing a lot of work in the pilot testing programs. So I would say, yeah, 5 years would be the horizon in my point of view.
Well, great, thank you. And since we're at the cooling systems, we also have a question about the coolants, and it's more about whether we cover it in our report, and to precisely say, do we cover the breakdown of the coolants, more information on that, information regarding the development of immersion cooling technology progress, and about key players, new coolant demands, and so on. Is it something that's in a report, Charbel?
We cover the present coolants extensively. The present technology, water glycol. We provide the split by the different additive technologies that are available. We provide a market breakdown by service field, market field segment. And in our forecast, we try to compute as well what would be the volume for theoretically for other type of liquids, and we describe what are the different players, what are the proponents of that technology. There are already few of them in Europe mainly, but also in Asia, and describe what would be the potential candidates, in terms of what would be the base stocks of the fluids to be used, and that's the level of information that we have. Obviously, as I mentioned, we are constantly reviewing and monitoring the changes, and certainly that will be a topic that will deserve a deeper dive, certainly in the next update of this report.
Great, so thank you. Gosh, reading more and more questions as you respond, so I'm trying to connect them all. There's one that actually came out twice, but in a different way, is because we cover in the report the mature automotive markets. Do we have more information about the rest of the world movement to EV? And also, and I know you do, you covered BCMO 2040 probably. We also had a question about the India market, right? We also have it in the new opportunities lubricants India, and we actually have recently written the article about two-wheelers and electrification in India. So the question overall, do we have more information beyond mature automotive markets and the movement to EV?
In terms of the electric, the penetration of electric vehicles in the passenger vehicle segment, yes, we do have another title that is called the PCMO 2040, the passenger car motor oil market in 2040. Again, a long-term forecast, and that's covering 15 countries, which is basically including India and other countries. This one for electric vehicle fluids is basically focusing on the regions where the changes will be the most prominent, and also in terms of the technological advancements as well. But in the passenger car motor oil 2040 study, there are 15 countries are covered.
Great, Thank you. This is good. And again, more and more questions about report. I guess we'll answer them separately. One more that I would like to ask, because I know we usually cover that in our other webinars, and this time you didn't, but do we cover competition? We're like, I'm not sure you want to reveal this, but do we cover the competition in the EV fluids market? And do we have like leading competitors and so on?
Yes, very good question. Actually, we do cover that. This is the first update. We published the first time this title a couple of years ago. At that time, we just, it was an emerging market. So there were literally a handful of players that were like just launching or announcing their dedicated EV or e-fluids products. At the moment, the market landscape, the competitive landscape is getting crowded. We did have effort to include who are the market share of those players, and also to provide the different product launches in the different, EV fluids categories in a chronological way. So we have dedicated a section to that. Certainly, most importantly, not about more like the market share or putting emphasis on the market share or the sales share, but more about what are their value proposition, what is the market positioning, and what the type of product offers they have. But we have included that in this update.
Great. Thank you. Thank you so much for all of these questions. We will respond to all of them via email because there's more and more coming, and we don't have much time for it anymore. And I'm sure Charbel will be happy to respond to you.
Absolutely.
Great. Thank you so much for all of your time, and I'll see some of you probably in the next webinar. I hope we see you. And actually, we have 2 more presentations. It's a pity I didn't have time to introduce it today. One on North American market and one on white oils in the near future. So watch out for that. And thank you for coming today. Thank you
very much. Thank you, Vera. Thank you. Bye everybody.
Bye, everybody.